We are given the sector of a circle ABC. Points D and E are on AB and AC. The radius of the circle is given by A, and AE and AD are of the same length, which is a constant multiple of A. Now take note that the value of K is less than 1. So the length KA is less than A. The line DE divides the sector into two regions which are equal in area. So you divide the two regions into equal area. The area of triangle ADE is half the area of sector ABC. Part A, angle BAC is given by pi over 6 radian. So this angle is given by pi over 6 radian. We need to find the value of K correct to 4 significant figures. We are given that the area of triangle ADE is half the area of sector ABC. So we can work on the area of triangle ADE. The angle of triangle ADE that can be given by 1/2 of AD AE sine theta here, this angle. So for this case here, the area of triangle ADE is 1/2. AD and AE are both KA. So you have KA times KA, which is the square of KA, and we have sine of pi over 6. Sine of pi over 6 is always given by 1 over 2. So area of triangle ADE, you will have 1/2 times 1/2, that is 1 over 4, K squared, A squared. The area of sector ABC, area of a sector is always given by half R squared theta. R here is A. So we have R half A squared, and theta is pi over 6. So that is 1 over 12 pi A squared. We know that the area of triangle ADE is 1/2 of the area of sector ABC. The area of the triangle is 1 over 4 K squared A squared. That is 1/2 times 1 over 12 pi A squared. So that 1 over 4 K squared A squared is 1 over 24 pi A squared. We can just divide throughout by A squared since A is a non-negative number. Dividing throughout by A squared, we have 1 over 4 K squared equals 1 over 24 pi. Multiply throughout by 4, K squared is pi over 6. And taking square root, K is plus minus square root of pi over 6. The K must be a positive constant. Otherwise, well, there won't be any triangle here. So K is a positive constant. We have square root of pi over 6. But your answer must be correct to 4 significant figures. So we compute square root of pi over 6 using a calculator, and that gives us 0.7236. That would be the value of K. For part B, for the general case in which angle BAC is theta, where theta is in between 0 and pi over 2, we are given that theta over sine theta is greater than 1. Find the set of possible values of k. The value of k is not unique here, but never mind about that. So again, the area of triangle ADE now. So from here, instead of sine pi over 6, we just have sine theta. That will give us 1 over 2. Then we have ka squared sine theta. So that is 1/2 k squared a squared sine theta. And the area of sector ABC is half a squared theta now. Instead of pi over 6, we have theta. Again, we use the fact that the area of triangle ADE is half the area of sector ABC. So half k squared a squared sine theta, that is half a squared theta. Okay, so let's see. That half and that half can be cancelled off. That a squared and a squared can be eliminated. Then k squared sine theta, this is given by half theta. Then we can divide, because we need to find the values of k. We do not need a sine theta, so we can divide throughout by sine theta. And k squared is 1 over 2 theta over sine theta. But we are given that theta over sine theta is greater than 1. So we multiply this by 1/2 because of the 1/2 here. So you have 1 over 2 theta over sine theta must be greater than 1/2. Now the right side, half of theta over sine theta, this is greater than 1/2, meaning that k squared must be greater than 1/2. K squared greater than 1/2, we can move the 1/2 over. Then k squared minus 1 over 2 is greater than 0. This can form a difference of squares. 1 over 2 is the square of 1 over square root 2. You can factor this to be k minus 1 over root 2 and k plus 1 over root 2. You can either use a sign diagram. It gets old after a while using the sign diagram. But k squared minus 1 over 2 is actually a quadratic curve. This is a parabola, and you can actually draw a parabola like that. It opens up because the coefficient of k squared is positive. You just think of k as x squared minus 1/2. It's a graph like that. And then when you set all these to 0, this is negative 1 over root 2. That is 1 over root 2. For this to be greater than 0, we are looking at these two intervals. So either k is less than negative 1 over root 2, or k is greater than 1 over root 2. But k is a constant multiple of a. It cannot be negative. So k must be greater than 1 over root 2. But k must be less than 1. So you know that k must be less than 1 from this part here. Therefore, the values of k must be in between 1 over root 2 and 1.